Alrighty, greetings and salutations, all those nice things. This is lesson 6.1. It's the first lesson in this whole topic of sequences and series, where sequences are essentially lists of numbers, and then series are sums of those numbers. In this unit, we will look at two particular kinds of sequences, arithmetic and geometric sequences, and then we're going to look at their related series, adding up all the terms in those particular sequences. So again, a sequence is just straight up a listing of numbers. They are separated by little commas. And if you want to suggest that the sequence keeps going on forever, you add the little ... at the end for it to just proceed. If you have some stuff after it, you say this thing ends at 121 or something, then it terminates. But without that, this thing is just going on forever. And these sequences could have patterns in them, or they might not have patterns in them. Right? Like this first sequence seems to just be all square numbers. So the next term might be like 36. And this bottom sequence, everything seems to be going up by same amount, so that's kind of neat. This third sequence, it just keeps bouncing back and forth between positive and negative 2. But this second sequence, I don't even know what's going on there. That's just seemingly random. They're definitely not all prime. Sometimes they go down, sometimes they go up by different numbers. It's a gong show. But those are all examples of sequences. And the one we're going to focus on most, or the one we're going to focus on in this particular unit, or this lesson, is this last one, the one that says 3, 7, 11, 15, 19. We're going to examine that for a couple of reasons. One is just to give us some standards for how to notate and talk about sequences and terms therein, but then also because this particular sequence has a certain property. So whenever we look at sequences, we can refer to the individual terms in those sequences. So Tn refers to the nth term. We've got that n in there as a little subscript. So it's not like Tn like that. They're not the same size. You have the T and then a little subscript n. It's also not a superscript n. It's not up here. That would be an exponent, and these are not exponents. This n just indicates which term it is. So the T says we're talking about a term, and then that n tells us which term we're looking at, where it could be term 1, or term 2, or term 3, stuff like that. So when we look at this sequence, 3, 7, 11, 15, 19, and then it keeps going on forever, ever. This 3 is the first term. That's T1. This 7 is the second term, so that's T2. This 11 is the third term. That's T3. And this 15 is the fourth term. That's T4. And this 19 is the fifth term. That's T5. So when we're looking for the value of T3, term 3, this is what we're looking at. Term 3 is the third term. That is 11. You're right, we should state that properly. T3 is equal to 11. Which term has a value of 19? Well, we scroll along this path and then, whoop, there's 19 there. And that's associated with T5, apparently. So the term that has a value of 19 is T5, or the fifth term. Oh, fifth is with an R? Nope. This particular sequence has a pattern in it. Take a look at this sequence, see what you notice, and see if you can get the values of the next 3 terms. If there are more terms, this goes on forever. We see those doodly-doos. So what are those next 3 terms? Take like 30 seconds, whisper to the people around you. Oh, assuming you did that, I know it wasn't quite 30 seconds. But you might notice, well, you're right. Now, I'm going to put the numbers down first and then see if they match up with what you got. I'm getting that the next term would be 23. The term after that would be 27. And the term after that would be 31. If you got those as the values of the next three terms, give yourself a way high five. Show whoever's covering this class how a way high five goes. And make sure it's way high. You don't want to give them a false notion as to what a way high five is. That's just embarrassing. If you got those terms, you got them somehow. How were those values determined? How many of you can actually say how you got those? Let's see a show of hands. Wow, okay. That's an amount of hands. Interesting. The way I got them was possibly the same way you did, whether you vocalized that or not. I did 4 to each previous value. This is kind of a defining feature of an arithmetic sequence. In an arithmetic sequence, we essentially add something, some constant value, to each term to get each next term. And we can always phrase that as addition. So by definition, here's how we define an arithmetic sequence. I'll read this out, give you a chance to write it down. Actually, no, you can just pause to write it down. But reading it out, an arithmetic sequence, I know it looks like it says arithmetic. It's the exact same spelling, but it is pronounced arithmetic in this context. So an arithmetic sequence is a sequence wherein there exists a common difference between consecutive terms. And that common difference is the difference between a term and the term before it. And you could say that's tn plus 1 minus tn. So this term, n plus 1, comes right after the nth term. But you could also find it as t2 minus t1, or t4 minus t3, or t20 minus t19. Just any term, take that and subtract the term right before it, and you get the difference. When you add the common difference to a term, you get the immediate next term. Oh, sorry, if you didn't pause to write down the definitions, just do that quick pause now. But the video's going to keep going. So if you take term 1, you add the difference to it, you get term 2. Oops, did I delete something? I don't know. There we go. If we take term 2 and add the difference, we get to the term 3. If we take term 18 and add the difference, we get to the next term, term 19, so on and so forth. In general, if you take the nth term and you add the difference to it, you get the term where the index is 1 higher. So instead of having like an index of 1, you'll get an index of 2. Instead of an index of 7, adding difference, you'll get an index of 8. What happens if we add d to t1 3 times? Let's take a look at how that happens in kind of a long format, and maybe we'll get a speedy way to do at least the last two. We'll go slow for the first two examples here, examples E and F. So we take term 1. If we go ahead and add d to that, then we get the second term. And that's by adding the difference once. If we add the difference a second time, well, now we've added the difference to term 2, so we get term 3. And if we add that difference a third time, now we've added that difference to term 3, so we get term 4. So the term we get is term 4. take a moment, see if you can get the answer for examples F, G, and H. You can do it this way. I would say do it that way for example F. Then take a look at what happened in examples E and F. See if you can detect kind of a pattern and how that affects the answers for G and H. Take a solid minute to try those out. Pausing the video and then resuming once you've given them a fair chance. All right, the answer to example F is T10. If you got that, give yourself a way friendly pat on the back. If you go kind of a slower way, we can say we started with T8, we added the difference, and that got us to term 9. But we're adding the difference 2 times. So we add that difference one more time, and if you add the difference to term 9, you get term 10. What we're seeing here is if you take this original index, this had an index of 8, we're at the 8th term, and add the number of times you add the difference to it, that's your new index. So 8 plus 2 got us 10, in the same way that 1 plus 3 got us 4. So in this next example, writing out this whole process 6 times is kind of a lot. But we can recognize that we're starting at term 23, we're adding 6 differences, so the new result will be term whatever 23 plus 6 is, which I guess is term 29. And if you got that without doing any of the work here, then you should give yourself a way high five. Here, we don't have a distinct number, but we operate the same way. In the previous example, we took 23, we added 6. In this example, we're taking n, we're adding 4. And what we get from that is t n plus 4. This entire thing is subscripted, this n plus 4. It's all a little lower and smaller, but smaller font than the t. But it's all grouped together. Can't be simplified because n and 4 are not like terms. That's all we can do with that. And that is that answer right there. So take that idea. Oops. I'm so sorry. Take that idea, see if you can determine how many times you would have to add the difference in order to get from term 1 to term 8. You can try one out as a long way, but kind of use the connection that we saw in these examples to get these ones. Take a few minutes, whisper to people around you as to what your process is, how you're getting that, and then pick up the video after you've given these a bit of a shot. All right, assuming you paused the video, gave these a shot, let's see. If we do this a slower way, we need to get from T1 to T2 to T3 to T4 to T5 to T6 to T7 to T8, and it's a bit of a process where we're adding the difference a whole bunch of times. How many times do we add that difference? Well, if I just count them, it's 1, 2, 3, 4, 5, 6, 7. I added it 7 times. 7. So that's the answer to example I there. But that's a slow method again. Yeah, drawing them all out, trying to count it, it's a while. Whereas we can just note this amount of times is just the difference in these indices, the 1 and the 8. To get from term 1 to term 8, we have to add the difference 7 times because that's how much of a difference there is between 1 and 8. So similarly, we've got term 3 and term 6. And if we just look at the difference there, we know that we'll have to add that common difference 3 times to get from term 3 to term 6. From T12 to T22, 22 minus 12 is 10. So we would add the common difference 10 times to get from term 12 to term 22. And to go from term m to term n, well, just as we took 22 and subtracted 12, we're going to take n and subtract m. Oopsie daisies. N and subtract m. Writing it in this way essentially gives us a bit of a way to link any two terms in an arithmetic sequence. Because the number of times we add the difference to one term to get another term is kind of defined by how far apart those terms are, we can say some stuff. To get from term m to term n, we must add the common difference n minus m times. That's what we said on the last page. Therefore, a couple ways we can write this. One's going to be a very Englishy sentence, and we're going to turn that into a formula. The nth term is what we're getting. We're getting 2 term n from term m. And the nth term is attained by taking the mth term, plus some number of differences, and that number of differences is n minus m. So that's kind of the Englishy sentence, the logic behind the formula we're about to write down. That formula says the nth term is attained by taking the mth term and adding n minus m differences. This is a formula that links any two terms of an arithmetic sequence. It is a formula that you can expect to get on a formula sheet, but you should be able to defend where it comes from using this kind of, this terminology right here. If we want, we could say that all arithmetic sequences are based on just their initial value and whatever that common difference is. So that initial value being term 1 and then d. So if we take this formula and we let m equal 1, then we're saying we're basing everything off of that first term. And the nth term is what we get when we take the first term and we add the difference, not n minus m times in this case, but since m is 1, it's n minus 1. So you can always use that formula as well. You can use either formula to work with any particular sequence that you're playing with. It's really kind of up to you. I would recommend locking this one into your head brain, but either works really, so it's all good. Everything from here is very formulaic. It's just kind of finding out what information we have and then plugging it into whatever formulas we have available so that we can get what we need. Like in this example, determine the value of the 30th term of the sequence 7, 11, 15. Well, worth noting, that goes up by 4, and then it goes up by 4 again. So we do have an arithmetic sequence. And for that, we can say the first term is 7. We could say the common difference is 4. Actually, we should show how we got that. So we got that as 11 minus 7, which is 4. N, the index of the term we need, is 30. We need the 30th term. So N is 30. And then what is that 30th term? I don't have a gosh dang darn clue. So we go to formula. Tn is equal to T, again, you can use either one. Let's use this, let's use the first one, the ones with the M's and stuff. Tm plus N minus M D, which tells us term 30, since all the N's are 30s, is equal to term 1, since that's what we're starting with, plus 30 minus 1 times the difference. And we also know what term 1 is. We know it's 7. So term 30 is, whoopsie daisies, 7 plus 29 times 4. You don't really have to do this part of the simplification as part of your work. Really, this whole thing is just going to be punched into your calculator, and you'll get a result from it. Whoopsie daisies. And according to the calculator, term 30 is 123. This is a 2-mark question. One of those marks is for finding the common difference, and then the other one is just for substituting into the appropriate formula. So if you substitute correctly and you get the right difference, then you get 100% of the marks. If you stop at this highlighted line down here, then you do get an E1 simplification error for not having it in this simplified form. Take a moment, try the other 2 examples on this page. If you're feeling really daring, you can try the 4 examples on the next page as well. But again, pause the video, give them a try, see how they go, and then I'll put answers on screen. So resume whenever you're ready. Wow, that was quick. Well, let's see what we got here. The difference is 88 minus 99, which is negative 11. So in the phrasing of this, we've phrased arithmetic sequences as saying we're adding something to each term. And we can still phrase it that way. We can say we're adding negative 11, and then again, adding negative 11. And that kind of consistency is in phrasing is pretty necessary. So it is, again, we're always adding something to get to each next term. In this case, we're adding negative 11. So effectively, we're dropping by 11 each time instead of this going up by 4. And then from here, plugging into, how you say formula? Formula says Tn is Tm plus N minus Md. So T15 is equal to 99 plus N minus M, 15 minus 1, and the difference is negative 11. You do that, you've got 2 out of 2 with an E1 simplification error. Finish it off. Just put this exactly as it's written into your calculator. Be mindful of the brackets. Make sure you're using negative signs instead of subtraction signs when there's a negative, and then subtraction instead of a negative sign when there's subtraction. Because your calculator might have a different button between the two. In any case, I get negative 55. And last example on this page, the common difference is, I'm just going to take term 2 and subtract term 1. So I'm going to take negative 19 and subtract negative 26. And we might not have to use calculator for it. Okay? But we should show where this is coming from. We can't just ignore all this and be like, D is 7, take it for granted. Show where it came from. Show that it came from taking one term and subtracting the term before it. So the difference is 7. The formula says Tn is Tm plus n minus m times d. So for us, we're looking at term 41. We'll start by taking term 1 and adding the difference, which is 7. How many times do we do that? N minus m. N is 41, and we are using term 1 as a basis, so m is 1. And again, calculator work time. So punch it directly into your calculator and get 254. So there's 4 more examples, and these other examples we're going to be asked to find other things. We're not going to be given directly this same information. We're not going to be given the listing of the terms of the sequence, but other information. We'll have to kind of parse apart what we actually have. So in this question, we're told T20, we're told T21, we need the value of the first term. And there's a few ways to go about this, but it's still a 2-mark question. One for finding the difference, and one for finding, or one for subbing into a formula to find T1. So the difference is term 21 minus term 20, if you want. So you can phrase it that way. You could say that, you could say that you get term 21 by taking term 20 and adding the difference, or you can say that the difference is what you get by taking term 21 and subtracting term 20. Either way works. We should be able to say that the difference is negative 34 minus negative 37. So the difference is 3. We need term 1. So we're going to have to link term 1 to either one of these, term 20 or term 21. Doesn't really matter which one you pick, as long as you pick a consistent one. Like you can say from this business that term n is term m. How do you spell m? No, that looks like an m. Plus n minus m times d. And if we're gonna let's pick term 20. That's the first one I see. So we'll just replace all the n's with 20s. We'll replace all the m's with 1s. We're going to say term 20. Well, that's negative 37. We actually know what term 20 is equal to term 1, which we don't know. That's what we're trying to find. Plus n minus m. That's 20 minus 1 in this case. And then times d. D is 3. And now we're solving that. It's probably advisable to write out your process here. You don't have to show a separate step of evaluating 20 minus 1 and then multiplying by 3. You can do that in one shot. Use your calculator if you want to try that out. Whatever 20 minus 1 times 3 is with all those brackets in place. But we should be getting 57 for that value. And then for a grade 11 skill, you don't need to show that you're subtracting 57 from both sides. You just need to actually do it. And you don't have to process that mentally for a question like this, because this entire unit is a calculator unit. So just negative 37 minus 57 on your calculating device, and we get negative 94. So that's that one done. For the next one, we're not given 2 consecutive terms. We're given term 5 and term 8. There's some other terms in between. We add the difference some number of times, though, to get from term 5 to get from term 5 to term 8. And we can say that term 8 is what we get when we take term 5 and add the difference 3 times. Adding once gets us to term 6, twice gets us to term 7, and a third time gets us to term 8. So we could also say that 3 times the difference is term 8 minus term 5. You can use your calculator there to figure things out. Subtract 82 from 121, get some number, divide it by 3. I think 121 minus 82 is 39, but again, calculator unit, so you can use that. And then 39 divided by 3 gets you a difference of 13. We again need term 1. So I'm starting with this formula just to give myself a basis from which to proceed. And I can use either of these terms. I can use, it doesn't really matter if you're using term 5 or term 8 here. I'm going to use term 5. So all my n's will be 5. I need term 1, so I'm just going to replace all the m's with 1's. Term 5 is 82. Term 1, we don't know. And then 5 minus 1 times the difference of 13. So, 5 minus 1 times 13, either in your head or on your calculator, that's 52. It's a deck of cards. And that's being added to term 1. Last step for this is just subtract 52 from both sides, which tells you that term 1 is 30. I'll tell you right now, when I was in grade, whatever it was, 11, I guess, and I was initially trying sequences here, I found I actually did have a lot of time on tests, because this is mainly formula plugging, and I could plug stuff into a formula all day, not to brag. My formula plugging in skills were as expected. I'm not going to say above expected. It's plugging into a formula. But if I want to double check things, I would just take my calculator, I would write the 30, and then I would add 13, and then I'd add 13, and then I'd add 13. I'd just make sure I got to these actual numbers. And if I didn't, then I did something wrong. But it's a way to back check your work. It's a manual and laborious process, but it works. Anyways, 2 more examples left if I know how to count. I'm mostly certain I do. Pause the video, give them a try, see what you get, and then resume the video to see if that matches up with the answers here. Go. All right, so you paused, you resumed. Here we are. 5 of the difference is what we're going to get by taking term 36 and subtracting term 31. So 5 differences is negative 45. 1 difference is negative 9. Formula says we get term 31 by taking term 41 and adding the difference some number of times. How many times do we add the difference to get from term 31 to term 41? Looks like 10, and that's because that's 41 minus 31. And, I messed this up. Jason, Michael, Joseph, Athide. This is why it's generally good practice to start with the old formula, plug things into the proper places. I'm going from term 31 to term 41. And that's what's dictating how I'm writing things out. So term 41 is what I'm finding. We have term 31, and we're going to add n minus m times the difference. From there, just plug into calculator. So whatever this whole side happens to be. All right, you already did it. Negative 45. There is another way to proceed if you want. We know that 5d is negative 45, and you could just say that term 41 is term 36 plus 5d, which is just 0 plus negative 45. Gets you to the same answer with fewer steps, if you want. But follow your heart. Anyways, last example. In the sequence 8, 11, 14, ... this goes on forever. Determine which term has a value of 389. So maybe it's like term 6, maybe it's term 7, maybe it's term 200, maybe it's somewhere in between. And we have to figure out what index we have to put to get a term with a value of 389. So in terms of what we know here, we know that for whatever n value that is, term n is 389. But we don't know what n is. We can get the difference. Difference is 3. And then we can say Tn is Tm plus n minus 1 times d. I don't know what n is. I do know what term n is. That's 389. For Tm, I'm going to replace all my m's with 1s. Oops. That should have been an m in the formula. So replacing all my m's with 1s. Term 1 is 8. N itself we don't know. And the difference we do know. So now we're solving this particular equation. You can do it a whole bunch of ways. Make sure you show some of your steps as you go along. I'm going to subtract 8 from both sides. So 381 is 3 times n minus 1. If you are more comfortable distributing this 3 to those terms, then feel free to go for it. Me personally, I'd rather just divide both sides by 3. 381 divided by 3. 300 divided by 3 is 100. 81 divided by 3 is 27. But again, you do have a calculator. So you can use that to your benefit. And then finally adding 1 to both sides. And this example is DUN, done. So, yeah, that's about that. Try some practice work, see how it goes. May the force be with you. And tell everyone I say hello. The end.